For example, if n is equal to 2, for example, if n is equal to 2, that is for second order filter n is equal to 2, right? Then k will varies from 0, 1 up to 2n minus 1. So k varies from 0, 1, 2 into 2 is 4, 4 minus 1 is 3. So k values mainly 0, 1, 2, 3, right? And for these k's values, we will get how many number of poles? 4 poles we will get from S0, S1, S0, S1, S2 and S3, right? So how to calculate those? To calculate the poles, we need the corresponding phase angle, right? So first we will calculate S0, that is 1, and K0, theta 0. So how to calculate the theta 0 now? Theta 0 is equal to pi, k is how much? 0 divided by 2 plus pi divided by, what is the value of n? N is equal to 2, so 2 into 2 is 4, it will be pi by 4 plus pi by 2. So first term gets vanished, so it is 0. So theta 0 is equal to pi by 4 plus pi by 2. So how much it is? Is it 3 times pi by 4? Yes, it is 3 times pi by 4. So therefore S0 is equal to 1 with an angle 3 pi by 4, right? And if you calculate this into the Cartesian form, so what you will get? Cos 3 pi by 4 is minus 1 divided by root 2 plus j sin pi by 4 is also 1 divided by root 2. Sin 3 pi by 4 is also 1 divided by root 2. Similarly, how to calculate S1? By substituting k is equal to 1, so that is 1 theta 1, and theta 1 is pi into k is equal to 1 divided by 2 plus pi divided by 4 plus pi divided by 2, right? So this is equal to pi by 2 plus pi by 4 plus pi by 2. So how much it is? So is it going to become pi by 4? Yes. So calculate what is. So S1 is equal to 1 with an angle of pi by 4. So how much you will get? You will get minus 1 by root 2, minus 1 by root 2 minus j 1 divided by root 2, right? And please remember, if you have 4 folds S0, S1, S2 and S3, the first 2 folds always lies in the left half plane of the unit circle. So this is unit circle. The first 2 folds always lies in this is the left half of the plane. So this is the left half of the plane and this is the right half of the plane, RHP. The first 2 folds always lies in the left half of the plane. You can check. This is S0. So this is X, this is Y. Minus 1 divided by root 2. Minus 1 divided by root 2 means somewhere here, and plus 1 by root 2 means here. So you will get the poles at this S0. And next is both are minus, so somewhere you will get here. So this is S1, right? And if you take S2 and S3, they will comes here. So you have to consider only the poles which lies in the left half plane of the unit circle. Understood? So don't waste your time in calculating other 2 poles, because even if you calculate also, you have to consider only the poles which lies in the left half plane of the unit circle. So I am not going to calculate the remaining two poles. So I will stop at only S0 and S1, right? So once you calculate S0 and S1, we have to calculate the normalized Butterworth polynomial, and that normalized Butterworth polynomial is calculated as Bn of S, right? So here this n is nothing but the normalized second order, so you can write B2 of S also, right? That is second order the normalized Butterworth polynomial, which is equal to right? So what you have to write here, this is nothing but LHP S minus Sk, right? So this is the summation, right? So here how many poles are located in LHP? Only to S0 and S1, right? So S minus S0 into, so this is a product, not summation, into S minus S1. Substitute. So here S minus, what is S0? S0 is minus 1 by root 2, minus 1 by root 2. So this minus into minus is plus 1 divided by root 2, minus into plus is minus j 1 divided by root 2 into S minus S1. So here both are positive, so this is 1 by root 2 plus j 1 by root 2, right? So if you simplify this one, you will get S square plus, you can simplify, root 2 times S plus 1. So this is the Butterworth polynomial, second order Butterworth polynomial, right? Then how to find the n-log transfer function? H of S is equal to 1 divided by Bn of S or B2 of S, that is 1 divided by S square plus square root of 2 times S plus 1, that is equal to H of S, right? So this is the normalized Butterworth transfer function for n is equal to 2, right? So this is the n-log filter, the Butterworth low pass n-log filter. If you want to find its digital filter, then you have to use bilinear transformation technique, right? That is S is equal to 2 divided by T Z minus 1 divided by Z plus 1. Wherever S is there, that S you have to replace it by what? 2 divided by T Z minus 1 divided by Z plus 1. Then you will get H of Z. So H of Z is equal to HA of S, where S is equal to 2 by T Z minus 1 divided by Z plus 1. Is that clear? And similarly for n is equal to 1, right? The Bn of S is equal to S plus 1. Therefore, the transfer function H of S for n is equal to 1 is 1 divided by S plus 1, right? Similarly, for n is equal to 3, you can calculate the transfer function HA of S in a similar way by calculating the poles, right? So you will get k number of poles. K varies from 0, 1 up to 2n minus 1. 6 minus 1 is 5. So you will get how many poles? You will get 6 poles, right? So out of those 6 poles, only first 3 poles lies in the left half of the plane. So you have to consider only those poles. What are those? S0, S1, S2, right? And remaining S3, S4, S5, they lies in the right half of the plane. So those poles we don't need. We require only the first 3. Therefore, Bn of S is equal to S minus S0, S minus S1, S minus S2, right? And you know how to calculate S now. This Sk is nothing but what? Theta k, and theta k is phi divided by pi k divided by 2 pi divided by 2n plus pi by 2, right? Here n is how much? N is 3 now. So it is pi k divided by 2 plus pi into 2 into 3 is 6 plus pi by 2, right? Now you substitute k from 0 to 6 now. So k is equal to 0. So you will get theta 0. You calculate, right? You will get some value. Then you calculate S naught is equal to 1 divided by this theta naught. You will get some function. Similarly, you calculate S1, S2 and simplify like this. So you will get Bn of S is equal to, how much you will get? For third order, you will get S square plus S plus 1 into S plus 1, and its transfer function is what? H of S is equal to 1 divided by S plus 1, S square plus S plus 1. So this is how we calculate the transfer function of the normalized Butterworth filter, right? It is nothing but the design of the normalized Butterworth filter. Is that clear? And it is basically a low pass filter, right? So in the next video we will discuss some numerical example based on this design of the Butterworth low pass filter. Thank you.